Hello, this is a unprofessional video of the Blunami BLU 2200 Steam version connection to Lego components. The wiring harness coming in on the left, and there's 4 wires coming out on the right, are attached to points on a breadboard for the demonstration. This is according to a chart supplied with the device when it comes in the mail. I think this is the same chart that they have on their website. To start with, I've got a 9-volt power supply from standard Lego power functions, and we're using just the inside 2 wires for power control. For the motor, I've got a battery-powered power functions train motor, and again, using only the 2 inside wires of the 4 that power functions cables supply. And then I've got 1000K resistors and 6 standard LEDs, and then a speaker that I had on hand. So the everything is a direct connect except for the blue wire, which appears to be the either the power or the ground for the LEDs. The LEDs are specifically aligned so that the cathode is on the blue side and the anode is on the resistor side. Then I've got a iPad here with the Blunami app. So I've launched that, turn on the power for the device. There's some sound that immediately comes out. You hear a beep, and the Blunami is connected. I didn't have to do anything with Bluetooth settings on the iPad to make that happen. I mean, I've got Bluetooth turned on, but I didn't do any pairing. So I'm going to pick just the standard train. It's reading the Blunami device. I went through several settings to try to get it to work well for the Lego motor speed and the sound of the speaker that I had. Just on the front menu, you've got acceleration control, a stop, settings area. This switches between forward and reverse. This is a quick stop, and this turns on the lights or turns off the lights. There's a long whistle, or I'm sorry, the bell. You can leave that running. Then there's a long whistle and a short whistle. The settings are where you, well, we'll get to that in a second, but on the pull-out, let's look at the 2 screens here, and just at the one specifically set up for sound and light. So the headlight's on, and I've got that on the first LED. Now if I switch between forward and reverse, the settings are set up to move to the second light there, which is the backup light. Then those other 4 lights are FX3, 4, 5, and 6. And on my second set of menus here, I can turn on 3, 4, 5, and 6. So all those are powered on. I'm going to leave those on just to demonstrate something. So back to the settings. There's a couple, these 3 settings that are the ones that I found useful. So if I go to the light settings for FX6, for example, which is the last LED I've got on the breadboard, I can change the light function. So if I want to do a double flash strobe, it takes a second and then the effect takes place on that light. And I'm not sure exactly how these forward and reverse directional controls work. I've experimented yet a little bit, but I haven't determined exactly how that's supposed to set up, although I know that the design of it is that when you're in reverse, it should power the lights on or off. If you're in forward, it should power the lights on or off. So that's the lights. And then on the sounds, there are a master volume, which I've got set pretty low. It can get very loud. So then you can adjust individually these sounds, and you can test them here by turning them on. Actually, I've got the motor off, so you're not going to hear any chuff sounds. But the whistle, for example, you can turn on, and you can adjust the volume here until you've got that where you want it. So there's sound levels here. And then, so that's light and sound. Now on the pullouts, there's a lot of different sounds that are already programmed in. For example, cab chatter. Some examples. So there's a lot to play with there. All right, now the motor side. So the way it came out of the box, it was too fast for running the Lego motor at too high of speed. And I'm still playing with that, but I've got this set in forward. I'm gonna start the speed up here a little bit, and then I'll do an all stop. And the chuffing of the steam engine it times with the speed of the train. So I had that set really low, and I adjusted that here under settings, speed settings. I turned the 28 step mode on, and then edited the speed table for 28 points. There's some options here, but I've got I don't know how 14 translates to the tables down here, but on the 28 point speed table, I've got these set to, these were like 10, 20, 30, or not that fast of a rate of change. But anyway, I've got these set super low just to make it move really slowly for this demo. But you can see where you can get a lot of control of speed and set a max speed in so that you can't go over a limit. So that's where the speed is controlled to the motor, and I think that's about all to demo. I've got the just an overall view of the breadboard. When I opened the Blunami package, the first thing I did was carefully strip the tiny wires and tin them so that they would be stiff enough to push into the breadboard. So now it's time to figure out what steam engine I want to build in Lego. I've got several that I already have, but I'll have to figure out how I'm going to fit all the wiring and the speaker into them. But I just want to do this video because I hadn't seen any yet on YouTube that actually showed a breakout of the wiring. And so there you go. Thank you. Bye.